Hello everyone, my name is Emmanuel, and today I'll be demonstrating my project on object-oriented programming using Java. So we have a ski shop here, and this ski shop holds products such as skis, snowboards, boots, bindings, and ski poles, and all of these products can be added to a cart. And let's go ahead and start going down the list of object-oriented design principles. So there are 4 design principles in object-oriented programming: encapsulation, abstraction, inheritance, and polymorphism. So we kind of overviewed our classes here, but starting from our product class, here is an abstract parent class. And then this parent class has these 5 child classes: skis, snowboards, boots, bindings, and ski poles. So essentially, a skis is a product, and a snowboard is a product, and boots is a product. So all of these classes extend product, and therefore these child classes inherit all of the parent class fields and methods. So a skis object or a snowboard object will inherit all of the product classes fields such as brand and model, and also the methods such as get brand and get model. So these would also be inherited from the child classes, and that is inheritance. And we talked about the product class, which is an abstract class. And since it is an abstract class, any abstract methods that it has, such as get item number or set item number, must be implemented in the child classes, which we have here: get item number and set item number. So you can see here it's implemented from the parent abstract parent class, and it overrides those methods. And so that is abstraction. And then we also have interfaces, waxable. The ski object or snowboard object can be waxed, and so therefore the skis is waxable and snowboard is waxable because they both can get wax jobs on them when purchased. So that shows inheritance, abstraction, and interfaces. And the last design principle of object-oriented programming is encapsulation, and that just talks about private fields and getter and setter methods. So you can see all of these fields here are private, such as price, gender, skill level, etc. And so we have the accessors or getters to get those fields. So get price is right here, or get type, or get sport. So these are all accessors to get those get the data from those private fields. And so that is encapsulation. And all of these products here, skis, snowboards, boots, bindings, etc., all of these products can be instantiated, and we can create instances of these skis or these products. And that is how we're utilizing objects and classes. And so we'll kind of go into a little bit of that in our next principle here, which is just discussing single and multi-dimensional arrays. So in our cart class, the cart can hold products. It can hold an array of products, or it can hold 2D arrays of products. So let's talk about single arrays right now. So you can see here we have a single array of products, and since all of these child classes are products, they can all fit within this product array here, because skis is a product, snowboard is a product, etc. So if we wanted to add a snowboard to a product array, we can add that into this array as long as they're all snowboards. Once we get into 2D arrays, or let's say we're adding two different types of products, a ski object and a snowboard object to our cart. Now we have two different types of objects in our cart. So to organize them in our cart, we have a 2D array of right here called multi-products. So basically it's an array of all 5 types: skis, snowboards, boots, bindings, ski poles, etc. And then if we wanted to add instances of these products, so basically a snowboard object or a pair of boots object, we can add that to this array according to their type of gear. So we can add an array of snowboards. Let's say if you wanted to buy a lot of snowboards, or if you wanted to buy skis for the family, you could have an array of skis in your cart. So that would be a 2-dimensional array. And that kind of goes into polymorphism. So as you can see here, these are 2D product arrays. And since we can have instances of all 5 types of these products, any instance that we create here is indeed a product. So an instance of a ski pole or an instance of a boot, they are all products. And so that's why we can have a 2D product array, because essentially what we're having is a product array within a product array. So that is polymorphism. And our last 2 concepts here we're going to discuss is exception handling and text file I/O. So text file input and output can be demonstrated here in one of our product classes, such as skis. So we have a method here called add to inventory, and it throws an I/O exception, an input output exception, and then we have a try catch block here to handle that exception. And within the try block, we're actually trying to access a file. So we're kind of doing 2 things at once here, exception handling and text file I/O. So we try to create a file here, open a file here, skisinventory.txt, since we're trying to find a ski or add a ski object to the inventory. However, if that file isn't created or is not found, it would throw a file not found exception, and then we would catch that exception here. And so what we're doing is we're catching that exception, displaying this little message, and then by just catching the exception and displaying the message, we're able to allow the program to continue running without completely halting the program. And so that is the benefit of handling an exception with the program. And now I'll go ahead and demonstrate how my project works. Let's open up the console here. So we have a welcome prompt here saying welcome to our shop, and then the next prompt is asking to enter an email. For sake of time, let's go ahead and just be a guest for the customer. And then the next prompt is asking if we know what product we want. Let's say yes, we know we want a snowboard. So we'll go ahead and type in snowboard. As you can see here, we have 3 results. These last 2 here are boots and bindings, because we have a type for boots and bindings. So these boots are for snowboards and these bindings are for snowboards. So that's why these results showed up. As you can see here, they are organized by type, and so that is the benefit of being able to utilize multi-dimensional arrays, so we can further organize products based off of type or even by model name. So let's say we're interested in one of these products. We will type in the first one, which is a snowboard. So we have the product information here, brand name, model name, type, gender, price, and sizes that are available, as well as a description. So let's say we want a size 145, and since there's one available, let's say we want 1. Add it to the cart. Yes, and let's say we want to just go ahead and check out. So we'll say no. Type in checkout, and you can see that we have 1 product in the cart, which is a Burton snowboard. And that is my program. Hope you enjoyed watching. Thanks.